This is a webinar where we are going to briefly do an introduction of CBRS, what it means, and hopefully it's going to give you some information that can be useful for any plans that you may have or any questions you may have of what to do to deploy and use the 150 megahertz of spectrum that is available today. So Citizens Broadband Radio Service, I also have it here as band 48 LTE. So in the LTE world, this is referred to as band 48. However, I want to make sure that this CBRS band is technology agnostic. So I just want to put that in the title because sometimes people uses the terms either way. The agenda for today is going to be, we're going to talk about the CBRS ecosystem. We're going to talk about the spectrum access tiers. We're going to discuss a little bit about the Citizens Broadband Service devices, which is the equipment that is allowed to operate in this band. Some regarding equipment choices, what are they, and some nomenclature for those. A new concept to the use of this band, which is the requirement of a certified professional installer, it's referred to CPI. And then I'm going to discuss a little bit the operation of what's required as a key component to make all of this spectrum available to everybody that wants to use it, which is the Spectrum Access System, or SAS. So we're going to go and talk a little bit about that. It is an overview of CBRS. This is a band or a spectrum that is available in the 3.5 gigahertz. It's 150 megahertz from 3.55 megahertz gigahertz to 3.7 gigahertz. This is also referred to as Part 96, the FCC 47 Code Federal Regulations Part 96. It combines aspects of licensed spectrum, as you will see, shared spectrum, and unlicensed spectrum or license exempt spectrum. Commercial operations for this band started in January of this year. SAS, as I referred to earlier, is the system or the key component that is used for authorization and management of the devices that operate in the spectrum. The access is provided across 3 different tiers, and we're going to review them and discuss them. And like I mentioned as well, it's a technology agnostic spectrum. There is nothing regarding the technology. One key element to use the spectrum is that it needs to use TDD communications. This is a map that shows everything that is in green, light green, and dark green is everywhere that you can operate in the CBRS band. You don't need to get a license. All you need to do is to use equipment that is FCC authorized to operate in the band. You will see on the coastal lines there is some red and pinkish color there. And the reason for that is because those are areas where there are incumbents and special attention needs to be placed into those. However, with the use of a CBSD authorized equipment and the SAS, you still have the ability to operate in those regions. You also see some circles on the northwest, in the LA area, and somewhere in the northeast as well. Those represent fixed satellite stations. They are also incumbents, and that means that they have priority. And as long as you have a CBSD compliant equipment and you're connected to the SAS, you still will be able to use the spectrum as long as you don't cause interference to them in that area. So how this was formed and what are the rules and specifications for the CBRS? So the FCC is the regulatory agency that defines the high-level rules. The Wireless Innovation Forum, it's an international group that developed the very specific and technical CBRS standards. What is the role of the FCC? The FCC rules basically define what is now called the Part 96, and they define the commercial use of equipment in the CBRS band. And the WinnForum, they basically define the requirements and protocols, all the signaling, all the communication, all the interoperability that needs to exist between SAS operators and CBSD equipments to operate in the CBRS. As of last week, there were 5 approved SAS providers. They are Google, CommScope, Amdocs, Sony, and Federated Wireless. So let's talk a little bit about the spectrum access tiers. The spectrum access tiers are what is referred to as Tier 1, Tier 2, and Tier 3. Tier 1, they are the incumbents. They have protection from everybody else to use the spectrum. Those are existing users like the Department of Defense or the US Naval Radar, and some existing users of the old 3650 megahertz license, also known as Part 90. Some of those users, they still have grandfather protection, and they are referred to as incumbent as well. So that's Tier 1. Tier 2 is they are licenses that are given into this spectrum. Organizations can purchase licenses for 3 years in a limited geographic area. Only the lower 100 megahertz of the band is for sale, and they can only buy spectrum in channels of 10 megahertz. And there are rules, specific rules about how many channels one organization can have in a specific geographic area as well. We're going to talk a little bit about that later. And then the Tier 3, which is everybody else that doesn't want to buy a license and is not an incumbent, they can use the spectrum, and they are referred to as General Authorized Access, GAAs. And it's open for everybody. In some geographic areas, the 150 megahertz may be available because there are no incumbents and there are no PALs. So they can use the spectrum, and the only thing that they need to abide by is that they cannot cause any harmful interference to Tier 2 or Tier 1s. So let's go into more details about each of them. So spectrum access Tier 1, the incumbents, who are they? So they already are using the band, and they are protected from interference. They have permanent priority. Like I mentioned, federal government are some of these incumbents. Naval ships and radars, that's what you saw in the map. All of the red lines on the coastal lines is because they have a lot of naval ships coming into the coast, and they use portions of this spectrum. So the SAS is going to be able to, there are some sensors, they are called ESCs, environmental sensing sensors, and they are deployed along the coastal lines, and what they will do is they will detect if there is one of these ships coming into the coast, and they will send all the information so that they can make sure, the SAS is going to make sure that any other operator is going to stay away from using those channels so that these users will be protected. The other users of this band that are incumbents are the fixed satellite services stations. They only receive data in this frequency, in this spectrum, but they also are incumbents, and they are protected from interference. And then I mentioned the grandfather wireless protection zones. So everybody that was using a 3650 megahertz spectrum according to Par 90 rules. There is a list from the FCC of organizations that got a waiver or granted some extension of when they need to change from Par 90 to Par 96. If you are not in that list, or you're not aware that you've received a waiver to operate in this spectrum with Par 90 rules, that means that you need to comply as of October 17 of this year. You should comply with the new rules. You need to be using certified equipment that meets the Par 96 specifications. Incumbents are protected by the SAS and the ESCs. I mentioned ESCs, the environmental sensing capability sensors, and they detect any use of the RF activity in the CBRS band, and they report to the SAS. And then the SAS has all the rules. They know what to do, and they should be able to manage and make sure that they offer protection as required to these users. Incumbent military ship radars and ground radars. Incumbent, they receive only fixed satellite stations, and like I mentioned, wireless users of using Par 90 devices that are phasing out. In the LTE language, they're referred to as band 43. This is the upper 50 megahertz of the CBRS band, which is from 3650 to 3700 megahertz. Coastal areas, this spectrum can be reclaimed by incumbent users. It's not always in operation. There are some areas that are more active than others. I think some information shows that the East Coast has more activity from this type of incumbents than they do on the West Coast, but really there is no definitive of which one is better. As long as the users are connected to the SAS, then they shouldn't have any issues connecting to this spectrum in any of these areas. And then the inland areas, this is where most of the satellite stations are located, and they are very well known. They will not change. They are not going to grow. Those zones are what they are today, and they are not going to change. If anything else, anywhere else, the spectrum is always available, and you will only have tier 2 and tier 3 users in that area. Spectrum access tier 2, these are the PAL, priority access licenses. These users, they can use the band when there is no incumbent user active in the same area. They can purchase licenses to get protection from GAAs. They can buy 10 megahertz channels at the county level, and they can only buy licenses from the lower 100 megahertz of the spectrum. The licenses, they are for 3 years, and they can be renewed after the 3 years. The licenses they are sold in auctions, and the cost is proportional with the population density of the geographic area. Only 7 PALs for every single county can be allocated. So that means that for every county, there will be 70 megahertz that can be used by a tier 2 user, and there will be 80 megahertz left for a GAA operator. So even though they can buy up to only licenses for the lower 100 megahertz, the way that the rules are written so that no organization can take most of the spectrum available in a single county is by limiting the number of channels that they can have in a county from a PAL. That's 7. And then for the same operator, they cannot use the 70 megahertz. One single operator cannot have more than 4 adjacent licenses for every county. So those rules are that way so that they can prevent one operator from monopoly, and ensures that anybody else that doesn't have a PAL or a priority access license, they still will have access to the spectrum, and they will have up to eight channels of spectrum available in any given county. And then the lower access tier, tier 3, is the general authorized access. They are allowed to use the entire band, the 150 megahertz. If there is no tier 1, if there is no incumbent and there is no PAL, they can use it all the time, 150 megahertz. They don't have any interference protection. They are license-free operation. They still have to comply with the SAS. They still have to connect to any of those operators that have a SAS. When the PAL is limited, if the PAL has 70 megahertz per county, then they can use the remainder 80 megahertz of spectrum. And then the same thing, they are always available to use the 150 megahertz of spectrum as long as there is no PAL in that county. I mentioned the grandfather operators that have incumbent protection. Most of this information is not relevant to all of the operators, but like I mentioned, the FCC put a rule that expired on October 17 of this year. And the rule was that any operator that has a Part 90 equipment operating in the spectrum from 3650 to 3700, they had until October 17 to migrate to the new rules, which is Part 96, and then and everybody that registered a site. The old rules, you had to go to the FCC website and you had a nationwide license, but you have to register every location where you were deploying a radio that was operating in this band. So any operator that has deployed these units and registered those sites before April 17 of 2015, all of those sites had that grandfather status that expired in the middle of last month. However, because of different reasons, the FCC is providing a waiver to some operators to operate for another 60 days or 120 days from October 17. And they have that additional time to put together a plan and a program to migrate to equipment that complies with Part 96 rules. That list of operators is published in the FCC website. This presentation has that link, so if you are one of them, you probably already know when your expiration time is. And then there are a few other operators because the nationwide license initially was given for terms of 10 years. There are some operators that their license will not expire until later in I think it's January 2023. So those operators still will be using the equipment with Part 90 rules, and they will not have to do any migration until after that, until after their license that they have today is going to expire. So what is a CBSD? A CBSD is basically any device that is transmitting energy in the CBRS band under the control of the SAS, the SAS. Typically, these devices are referred to as base stations or access points. They must communicate with the SAS before they can use the CBRS band. they only receive permission from the SAS if they won't be causing any harmful interference to an incumbent or a pile, depending on the tier they belong to. If it's a tier 3, they don't have to cause any interference to tier 2 or tier 1. And if they are a tier 2, they don't have to cause any harmful interference to an incumbent. The authorization, they can gain authorization of using the spectrum transmitting at the lower power. And end user devices are not considered CBSDs. Like again, CBSD is only a device that is transmitting by definition of the rules that are connecting to a SAS. An end user device, which is a device that is transmitting at the lower power, maximum EIRP for those devices is 23 dBms. They are not considered CBSDs, and they do not have to have connection to the SAS. They are what's called an end user device. The next slide, I'm going to show the different categories of equipment that transmits in this spectrum. This is from the FCC rules. These are the categories. So you have a category A CBSD. The definition of this device is a device that is not transmitting at more power than 1 watt for every 10 megahertz, so 1 watt per channel. They can operate in indoor facilities. If they are going to be installed outdoors, they cannot be installed at a height above average terrain of more than 6 meters. If that's going to be the case, then the device, the CBSD, is going to be considered a category B. And then I mentioned CPI installation, so I'll talk about CPIs later, but if it's a category A and there are some things that cannot be, the device itself cannot communicate to the SAS, like the geolocations with some accuracy, if that information is not available from the CBSD to the SAS, then there is a need for the CPI to intervene and is required to perform that installation. The category B CBSD device is a device with, that is allowed to transmit at higher power, 50 watts for every 10 megahertz channel. They cannot be deployed in for indoor operations. They are only for outdoors, and they cannot. There is no restriction of the height of the antenna that the unit is going to be operating at, and it always requires the installation always requires a CPI to convey information and to validate the information with the SAS. And the reason for that is the SAS is the key element that guarantees there is not going to be interference to incumbents and PALs. So there is a need for a CPI to validate all of that information so that the SAS can do all of the analysis that it needs to do to make sure that it's not going to have devices, it's not going to allow devices that are going to cause any harmful interference. And then the end user devices. So before I do the end user, so these two devices, category A and category B, they cannot be used for mobility. In other words, once it's defined in the location where it's going to be transmitting, it cannot operate while it's moving. It cannot be operational while it's moving in any other facility like a train or a car. They cannot do that. The only device that is allowed to operate for mobility is the end user device. The end user device is not categorized as CBSD. The maximum power transmission is 200 milliwatts. It must be under control of a CBSD, but there is no requirement for the end user device to have communication to the SAS. So that's the main difference between these. These are the three main categories of equipment that you're going to see in using the CBRS spectrum. Equipment choices. Uh, the CBSD devices, so you always have what is called as the base station. In LTE language, it's referred as E node B, or access points for Wi-Fi, or access point for most of the other technologies. They are referred to as access points. They are CBSDs, and they typically transmit as a category B device. They are probably high power devices, and they need to reach out to multiple of other CBSDs or even end user devices. So these are category B devices that will be part of the network. A CBSD can operate in category A or B. The FCC nomenclature for this is there are two nomenclatures to make a differentiation between the two. A CBSD device is a category A or category B device that has direct connectivity to a SAS. In other words, it doesn't need to relay communications to another CBSD to connect to the SAS and pass all the information that the SAS requires to be operational. And then there is another definition of a CPE CBSD device. And this is a definition because CPEs are not end user devices. A CPE CBSD is a device, it's actually like an end user device, but it's transmitting at higher powers, high powered, like maybe 1 watt or anything above 23 dBms is going to be considered a CPE CBSD. So it can be a category A or a category B device. The difference between CPE CBSD and BS CBSD is that the CPE CBSD will have the connectivity to the SAS is by connecting to through another CBSD. So if you think of this as an end user device that is connecting to let's say it's an LTE network. So you have the CPE connecting to the E node B, but because this is a CBSD, this CBSD has to have connectivity to the SAS, but the way to connect to the SAS is going to be through the E node B. So that's why it makes the difference. And then the end user device, it's the only device that is allowed to operate for mobility. It's a low power device and is not controlled by the SAS. What are the typical devices that you will find as end user devices? Are the cell phones, tablets, laptops, anything, or even a hotspot in your in your house that is an indoor device where you can get a CBRS channel there. So those are the typical, the different type of equipment that you're going to find in the CBRS industry today. Now let me talk about the certified professional installer. Like I mentioned, the information, the SAS has all the relevant information that is going to use to guarantee that none of the CBSD devices deployed will cause harmful interference to an incumbent or a PAL user. So for that reason, they require the certified professional installer. This person is responsible for relaying CBSD installation to the SAS, ensuring that high priority CBRS users are protected. They have to take training accredited by the WinnForum. There are some companies that offer this certification. More likely, one of those 5 authorized SAS providers have training material and a certification program so that they can become a CPI. They could be physically doing the installation. They don't have to, but they are responsible for entering the information into the SAS. They need to be the ones getting that information into the SAS because they have the credentials to log in into the SAS and provide security information with cyber certificates that demonstrates that they are a CPI. Could be signing off on a physical installation, and the person doing this work is 100% responsible for installation parameters sent to the SAS. This is important to note because the CPI may be working for company A. However, the person that is liable for the integrity and validity of that information that is going to the SAS is not with company A. Is the CPI. It's the person that has the responsibility to making sure that that information is accurate. So now I'm going to talk a little bit about the citizens broadband radio device, the basic operation. I'm going to talk a little bit about how they communicate to the SAS, what is the information that they need to communicate with the SAS, and the SAS, how it works a little bit as well. So the CBSD, the SAS allows multiple active devices in the same channel. Like I mentioned earlier, the CBRS is technology agnostic. The CBRS is TDD, uses the same frame configuration across the network, tries to synchronize frame configurations with neighbors. That's for mitigating interference. The CBSD must meet several prerequisites before it can start transmitting. So the CBSD must be approved by the FCC before starting communication with the SAS. And that means that it must comply with all of Part 96 rules. But also it needs to be tested and approved by the FCC for communicating directly with the SAS or communicating via domain proxy to the SAS. So in addition to complying to the RF parameters that are defined by the FCC, it needs to be certified that it can connect to the SAS, either directly or using a domain proxy. A CBSD may be used only as indicated in the FCC approval. So it will, the label in the unit is going to say if it connects to the SAS using a domain proxy or directly. The information of the FCC ID and the URID installation parameters, which are like location, elevation, antenna gain, antenna azimuth, tilt, antenna beam width, they need to be relayed to the SAS. Some installations, some devices will be able to convey this information on its own, but it still needs to be validated by the CPI. The location accuracy needs to be within 50 meters horizontally, and then within 3 meters vertically, so the elevation within 3 meters. CBSDs, they need to be known to the SAS, and they need to be and the information to the SAS. They need to convey power transmission, registration time, everything that is going to make the SAS do all the calculations to avoid any harmful interference. That information can be relayed to the SAS in a single step or multiple steps. However, the SAS will not send a grant to transmit to the CBSD until all of those parameters are successfully conveyed to the SAS. Before that, the CBSD device will not be able to transmit at any higher power. The SAS dynamically registers CBSDs, grant access to the spectrum, and authorizes CBSDs frequency and power level. So once you connect to the SAS, you tell the SAS this is your relay information, antenna, everything that has for that particular location. The SAS is going to do some calculations and is going to relay back, okay, these are the channels that are available for you to transmit. This is the power that is available for you to transmit. And then if you, if the information that is coming back from the SAS is those are parameters you can use with the CBSD, then the CBSD is going to be using some of that information and start transmitting in the spectrum. This is just these diagrams come from the WinnForum standards documents, and it's just a quick flow diagram of shows how the SAS allows the operation of a CBSD in the spectrum. So you have let's say you have a CBSD device. As long as the CBSD is not registered, it's not going to be transmitting. It's going to attempt to register by sending all of the required information to the SAS. If it's a category A, is some information that is required. If it's a category B, then it's additional information that is required. The registration can happen, like I mentioned, it can happen via CPI or directly from the CBSD. Once the unit is registered, the SAS is going to look at the information, is going to check for what spectrum is available, what transmission power is going to be available for each of the channels that are available, and is going to send that information back to the CBSD. Once the CBSD receives that information and says, yes, this is I'm going to start using this channel, I'm going to transmit at this power, then it sends information back to the SAS. The SAS says, okay, you're going to transmit, sends a grant back to the CBSD, and then once that is happening, then the CBSD is going to start transmitting what is called the heartbeat, and that information is going to tell the SAS that is authorized to transmit, and the authorization of that, or the grant of that operation, of that license to that of that channel, of those parameters to that CBSD, are really defined in a contract, or the contract that a SAS operator will have with the CBRS operator in this geographic location. Now I'm going to really talk a little bit of the SAS operation and the 6 steps that are taken by the SAS to allow operation in the band. This comes from the information, this diagram comes from the WinnForum requirements. And this is basically what the SAS is supposed to do, is actually doing. It determines the available frequencies in a given geographic location and assign them to the CBSDs that want to operate in that geographic location. It also calculates the maximum permissible radiated transmission power for those CBSDs at the given location and sends that information to the CBSD. It registers and authenticates the CBSD and provides the information on the location to the SAS. It enforces exclusion zones to ensure compatibility between CBRS users and incumbent federal operations. So this basically is providing protection, interference protection to incumbents in the geographic location. And it also protects the PAL users the same way from harmful interference from general authorized access users. And ensures secure transmission of information between the SAS and the CBSDs. Is worth to point out that you can have, as an operator, more than one SAS operator to connect to the CBRS network. And once you pick a SAS operator, it doesn't mean you have to have all your network deployed with that SAS operator. There are rules that make the different SAS operators to have interoperability, and they share, and all the information for all of the CBSDs is shared among all of the SAS operators. So you can use different SAS operators in different geographic locations. There may be some benefits for some operators to use different ones. So that's just something worth to point out. The CBSDs, these are the 6 steps that they need to happen from a CBSD perspective in order to ensure that the SAS is going to allow the operation of that device in the spectrum. One of them is the registration. CBSD tells the SAS all the critical details about the location and the CBSD and the power transmission, everything, and receives a unique identifier from the SAS. During the registration, so there is some information coming from the manufacturer, some information, the FCC ID, all of those elements actually are already with the SAS operators, and they will know if the equipment that is trying to connect or register for with the SAS, they will know already if it's equipment compliant with the FCC to transmit in Part 96. The CBSD is also going to do a spectrum inquiry, the CBSD mechanism for learning what spectrum is available, given its location and installation characteristics. The SAS is going to grant request. So once the CBSD requests a grant to reserve a portion of the spectrum for use, once approved, the reservation has been made, but the CBSD is not yet authorized to transmit using the grant. Remember that flow diagram? So I'm registered and I have a grant, but I cannot transmit yet. So what's going to make that transmission possible is the heartbeat. So the heartbeat is going to be sent by the CBSD. It's sent in different, like I said, different contracts or different agreements that the operator may have with the SAS operator, may have a request of what that heartbeat needs to be. A typical heartbeat period is about 4 minutes to 5 minutes. But like I said, that really depends on what agreement you may have with the SAS operator. And once you start transmitting these, then you will be allowed to receive authorization from the SAS to start transmission. And once you have the authorization to transmit, you just continue to operate as normal. You still need to send the heartbeat. If something changes because you're in a region where there is an incumbent that is going to come up because you're in the coastal, any of the coastal lines, or you're close to a fixed satellite station and you need to do something, you're going to get some information from the SAS, and the SAS is going to tell you what do you need to do. And you need to reduce your transmit power, you need to change channel, you need to turn off your transmission for a number of minutes. All of that information is coming from the SAS, and part of the certification of a CBSD equipment is to make sure you comply with all of those requests from the SAS. The SAS is going to relinquish a grant. When the CBSD doesn't want to use a grant, you can send a request to relinquish it. Sometimes the way you do this is in combination with the next step, which is the registration. So if you're going to take down a piece of equipment, you want to relinquish a grant and then do the registration. Or if you're going to move the equipment, if you're going to move the equipment for any reason, you need to make sure that you do the registration as well. So once you do the registration and you move it, then you're going to start the process again of registration and everything else that you need to do to start transmitting at the new location. This is a typical architecture with the LTE technology of how you can have access to the CBRS spectrum. I'm showing here is Telic. Telic is one of Council Rock products that operates in this band as well. It's a category A or category B device that you can use, or an end user device as well. So the idea is if it's an LTE network, you have to have all of the elements that make part of the LTE network. You need an EPC core, and you have all your management network and everything on the back office. But what's important is that what I show here as an eNode B, that's a category A or category B device. It needs to have connectivity to the SAS, and the Telic or the CPE device here, if it's an end user device, if it's mobility, you don't need to have connectivity to the SAS. But if it's a category A or category B device, because it's connected through another CBSD device, which is the eNode B, it will have to rely some communications to the SAS in order to continue to operate. So this is how you will deploy a typical LTE network operating in the CBRS band. Like I said, CBRS is technology agnostic, so it doesn't have to be LTE. It can be any other technology that is, it complies with Part 96 of the FCC. Most of the information that was presented in this webinar can be found in the WinnForum CBRS knowledge base. You will find all of the requirements for commercial operation in the US. You will find all of the protocols and all of the standards for signaling and communication between CBSD, SAS, SAS to SAS, all of those requirements and how is everything tested. You're going to find it in the WinnForum knowledge base as well. And you will also find information in the same website for the Certified Professional Installer Accreditation Technical Specifications. With that said, that's the end of the webinar. I hope this information was useful for all of you, and is going to give you a little bit more information of what are the steps that you may need to take if you want to start using this 150 megahertz of spectrum that's available to everybody now with the use of the SAS and CBSD equipment.